Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled the Einstein Cross Gravitational Lens. So, what do we see here? Well, here we see an image of a galaxy which looks like it has four separate nuclei. And we can see four separate dots there in a little pattern or diamond pattern around the center. And what those are actually nothing to do with this galaxy at all. They are not the nucleus of this galaxy, but are actually images from beyond the galaxy, and in fact a quasar that is located beyond that. Now the quasar is actually the central core of a distant galaxy, and many of these are many billions of light years away, much farther away than just a typical galaxy that we'd see. And when things line up, they can act as a gravitational lens. So what happens is the quasar is directly behind this galaxy, and the intervening galaxy then acts as a lens and bends the light as it travels around the galaxy, making it appear that the light comes from all different directions. This is what is known as an Einstein Cross, which you see when you get things pretty well lined up. You can get things like an Einstein Cross or an Einstein ring, where you get a perfect circle around when everything is aligned just perfect. And this all has to do with general relativity and how general relativity sees gravity as a bending of space and time. Essentially, the galaxy is bending space and time around it, and the light has to then travel through that deformed space and time in the shortest path it can, which is all slightly different depending on what direction it's coming from. So we get these four different images, and we can see them that they'll vary in brightness. And that is because of the distribution of matter within the galaxy itself that will change the paths a little bit, and also due to what is known as micro-lensing. So not the overall lensing due to the galaxy, but individual lensing due to individual stars that are also bending the space and time around them and affecting the light paths. So we can get all different things like this, and we see many cases of gravitational lensing like this in the universe. But to see the Einstein Cross or the ring requires that things be lined up almost perfectly. In general, we'll just get various different arcs because the alignment is not perfect. It's only in those very rare cases where the alignment is perfect or very close to perfect that we get images like the one we see today that shows some of the predictions of general relativity in terms of the bending of space and time by a massive object, in this case a galaxy, although we see very similar things for whole galaxy clusters that can do the lensing for even more distant objects. So that was our picture of the day, titled The Einstein Cross Gravitational Lens. We'll be back again tomorrow for the next picture, previewed to be Box Star. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.